I think we could start up just for everyone to know. First time on there, tech school is kind of like this 101. We're kind of class on certain topics, not always technology, even though today's on machine learning, but we did one on leadership and other interesting topics before. Stephen, who's been leading our internal tech school, said, let's do something externally. Let's expose other people to what we learn at Fokcus. So he's an amazing developer and teacher, and really great at just allowing certain concepts to be in somewhat this one-on-one form for our startups. So thank you, Stephen. You're on mute now, but I'll totally hand it over to you. Everyone, if you have some questions ahead of time, we would totally want you to actually just use chat. Chat's been working out really great, and I think it's kind of a way we can kind of formate certain themes of certain questions. So use your Zoom chat to go on. We are streaming to YouTube live, and so I think that's gonna be really fun. I feel like the YouTube live gives us another level of aspects of some of our friends who are like at USC and UCLA will probably be giving those links so they can actually listen in. Anything else? Hey, how you doing, Austin? Anything else, Stephen?
No, I think we're good. Yeah, thank you, Curling. I would just say that for those of you who, let's say, have to jump off, partway through this kind of chat today, or maybe get disconnected or something like that, we will post this on YouTube too. So if you, for whatever reason, have to step away and want to catch the rest of it, or want to rewatch any bit of it, we will do that too. So I did want to mention that. All right, so I will share my screen and we'll get going. All right, so today we're going to talk a little bit about how to leverage machine learning, mostly for startups and businesses. And so this is kind of a pretty technical topic, right? Machine learning. And we're going to try to come at it from a little more of a non-technical perspective, from kind of a business or economics perspective versus just straight, technical lingo and all that fun stuff that you might hear if you kind of dive into the data science part of it. So that's kind of the way or the point of view we're going to try to have today. So what on earth are we going to be talking about today? So number one, we'll talk about the consequence of prediction or, machine learning in today's world. We'll talk about where we start with machine learning, right? So when is machine learning useful, and then what kind of problems we can solve with this? And then we'll dive into kind of looking into the future and what that means as far as these technologies and what they might evolve into later on. So just as kind of a forward here, so the ideas from today's talk are taken from a book that kind of covers machine learning and data science from kind of a business or economics perspective. And so kind of the framework I thought was pretty useful. So if you guys want to learn more, you guys can dive into this book, Prediction Machines, and learn a little bit more from this perspective as well. And there will be stuff in here from, that are not related to the book, but just wanted to give you guys some sort of material if you guys want to dive into it some more or learn some more from that. So about 5-6 weeks ago, we did talk about big data, and I know big data kind of sets the stage for machine learning. So we'll start with there and do kind of a quick recap. So big data, for those of you who don't know, is kind of this term for this rapid expansion of information that we have today that's kind of happened over the past few decades. And it's gotten to a point where there's over 2 quintillion. Quintillion is about 2 followed by 18 zeros, to give you some context, is about the number of bytes, or it's over that amount of bytes of data that are generated each day, just by people, things, devices, whatever that may be. So there's a lot of data that's being generated, and that of course ties into what fuels a lot of machine learning and what it can do. So this of course will influence the future. A lot of this ties into machine learning, giving enhanced insight to businesses, decision making. It'll cause things to be automated. It'll create jobs, a lot of fun stuff that we'll experience, that have happened probably over the last few decades, but it will continue to, kind of experience in the future. And this idea that data in and of itself and machine learning are complements, right? They complement each other. The more data we have, the more useful machine learning can be. You know, so that's all, fine and dandy. That's awesome. So how do we get started with all this, and what does this all mean? So we will start with kind of asking the question, what is machine learning? So machine learning has kind of been this buzzword for a lot of us that might not be directly involved with it, that we might hear a lot, and that it can solve problems and do a lot of fun things. So what does it mean? Well, at its core, machine learning is kind of just an avenue for prediction, right? It allows you to be able to predict things and maybe even predict things that are very complex that, maybe would be very hard or very difficult for, let's say, a person to do, right? Or just makes things easier. So that's really cool, but we know that it has to do with prediction, but might be a little lost on what that means for you, what that means for your business. Okay, how is that useful to me, right? So how does prediction help me? Well, if I kind of shifted a little bit and told you that prediction is kind of this key component of decision making, it kind of opens up, a different type of mindset, right? Because decision making is, core for any business, right? Making decisions and whatever those decisions may be. So as decision making is kind of a key component of any business, that means that in and of itself, prediction, can help a lot of people out. So from a economic perspective, as things become cheaper, they become more widely available, right? And machine learning is no different to that fact. So as the barrier of entry to machine learning kind of lowers, right, it becomes easier to access kind of this technology, it becomes more widely available. In today's world, you don't necessarily need a PhD in data science or need someone with a PhD in data science or machine learning or computer science to be able to get started and use machine learning for your business. 20 years ago, 30 years ago, to be able to really use it, should that technology exist for you to actually use it, you may need an expert to help you out. But today, there's a lot of tools to allow you to be able to get started and get it up and running without having to know everything there is to know about data science. And to give you guys some context, just to give you guys kind of an example here, the advent of artificial light, right? If you were to look back in the 1800s, artificial light, something that we experience, just about everywhere, right? From turning a light switch and any sort of light bulb you may, have, it cost, more or less about 100 times as it did today for you to actually access artificial light. And if it would still cost about that same amount, would you still use it the same? Well, you'd probably be, a little bit more reluctant to, leave the light on maybe in rooms in your house or, whatever that may be, right? You might be a little more safe and secure on how you actually, use light. And now, thankfully, that has become kind of widespread and cheap as years have gone on, and now we experience, the advent of artificial light just about everywhere, right? And so this creates widespread value, right? And so this changes industries and ultimately people's lives as technologies like this become cheaper and become more widely available and accessible to, businesses, to people who are actually, changing industries, and then ultimately, the people that use products and services and things like that. So now let's kind of, dive a little bit into prediction. So when we think about, using machine learning in terms of prediction, there's a lot of thresholds when it becomes useful. And a good example of this is something taken from that book I mentioned. There was a challenge that's been going on, I guess, for about a decade or so. It's called the ImageNet Challenge. And the goal of that is to predict an object from an image, right? So image recognition. Now today, there's a lot of companies that do a lot of fun things with image recognition, but back in 2010, there wasn't, a lot of those didn't exist, right? And so this was kind of a challenge to see how accurate you could get with, predicting, objects in an image and all that fun stuff. And so this graph kind of illustrates the average error that occurred by teams that participated in this competition. And as we can see, they have kind of this human benchmark that's listed, right? So if you were to take the average person and have them, tell you what's in that image, they would be about 95% accurate, right? So they had about a 5% error rate on average. And so over time, machine learning, based on, the data they were able to use to train these models and all that fun stuff, and just the improvement over time, they were actually eventually, around 2015, able to, on average, beat that human benchmark, which is kind of cool, right? So now this image classification, became more useful for the average consumer, or it had more things you could use it for, because now we're actually providing more value than just having a person, predict what object that is in this image, right? So that's kind of a quick example or a use case of prediction and what that means. So machine learning at its core will impact decision making in businesses, and so I want to dive into that a little bit. So machine learning has kind of this immediate impact, or the fastest impact in businesses at the decision level, right? So the decisions that you may make on an everyday basis, on a weekly basis, or whatever within your business. And so kind of a way to illustrate that, or to illustrate kind of a task or some sort of decision that gets made, you can break it down into its kind of fundamental components here. And then pieces of this can actually be done by a technology like machine learning, or you're able to leverage it to make this easier for you. So you have some sort of input, and then a person might make subconsciously some sort of prediction based on what they know, training they have, experience they have, whatever that may be. They may have some sort of judgment based on the value of whatever actions you might take based on that prediction, and then ultimately you make an action. It has an outcome. Whether it was good or bad or whatever happened, you may learn from it. There's this feedback loop involved, and you ultimately kind of have another piece of data to be able to train and build off your own experience, right? The same way that kind of this same dynamic happens when let's say we sit in a classroom and we learn, right? You learn mathematics, you predict, okay, here's what I think the answer is based on my experience. You're solving a problem, you have some sort of judgment based on that, and then you end up with an outcome. Was it right or wrong, on a test, exam, whatever it may be. And based on that feedback loop or whatever, you're able to train yourself. You're able to learn from that, right? So this is kind of this basic anatomy of decision making, that if you can, let's say, break down something that happens in your business, or a decision that happens in your business, then you can ultimately break it down into parts where, okay, where would machine learning actually be useful in this decision making process, right? And so that's kind of the first step into figuring out where machine learning kind of fits in and how it can be useful in your business. And ultimately, this is kind of this framework that a lot of, let's say, startups and companies nowadays over the last 5-10 years have looked at problems in our world and said, okay, we can solve that with machine learning, or we can ease this whole process or this decision that happens in somebody's everyday life to be able to leverage this technology to make that better, right? So this is something I think is pretty useful for startups and for those of you who want to use machine learning in business. So what about judgment, right? So we talked about prediction, we talked about making actions and that decision-making process. Now the judgment part of this is the inherently human process, right? So this allows us to actually express rewards for different actions that we may take. So for example, think about like the likelihood of it raining today. So, I'm currently in Oregon and it's, a rainy day outside, but if it's all fine and dandy to know the likelihood of it raining today, but for you to actually know how much that means to you, you have some sort of judgment on what sort of value that means, right? Do you really like to stay dry? Do you just hate carrying an umbrella around and it's more worth it to you to just get wet or wear a rain jacket, right? So all that comes into play and really influences the action you take, right? And that judgment is this inherently human component that a machine or an algorithm or something like that can't do unless it's told, right? Because we ultimately know the value of these types of actions that happen, in our everyday lives or in business or whatever they may be. Another example of that would be predicting credit card applicants' credit worthiness. So you may find, depending on, you submit an application to, credit card company Y or credit card company X, you may be able to be approved for different credit cards at different rates or whatever. And that whole, depends on the risk and default rates and all that fun stuff that comes into play. And so they've been able to, automate some of that prediction process to be able to, ease that versus a person having to look at that application, make a prediction on, okay, here's how much risk we think this person is worth, and then making a judgment on how much risk, or if that company is, willing to take on that risk and what that means to them in what, let's say, credit lines they're able to, approve you for, credit cards or loans or whatever that may be. So that's another example of, prediction and judgment and things that machine learning can actually, come into play here, and what that may look like and as a piece in that puzzle. So ultimately, why is, machine learning useful? Well, algorithms in itself, other than what we just talked about in prediction, can be less biased than humans when making predictions, right? And this just comes into play because, we have our own experience to draw from, or experience of others, things we've heard or whatever that may be. And there's a lot of times we don't have the whole picture or there's a lot of complex kind of things to take into account. And so algorithms can kind of lessen that stress and help us out, and allow us to be able to, do that a lot quicker and easier. And there is a silver lining though, right? So in the same way that, if your experience is biased and it's going to allow you to come to some sort of conclusion, if the data that you feed a machine learning algorithm is also biased, it can also create a biased prediction, right? In the same way it would with a person. So those are also things we're going to, be able to consider as well. And we'll go through an example of something like that a little later. Now, machines work very well with complex interactions between many different indicators. So think of like a lot of different variables you're trying to take into account. So trying to predict whether, in the movie Moneyball, for example, trying to predict whether, let's say, a prospective baseball player is going to be a good fit for your team. There's a lot of different statistics and a lot of different data points to take into account. And it'd be very hard for a person to do that. Well, machine learning, is able to allow us to look at that full scale easier than a person could in a lot of different situations. Now, rich data sets are kind of this sweet spot for machine learning, places where we have a lot of data. Examples of this are, detecting fraud, or in, let's say, credit card companies, or transactions, or medical diagnosis. These are kind of areas where we have a lot of data, and so machine learning can be very useful because we have a lot of this data to be able to look at. And this also ties back into the big data we talked about before, and all the data that's being generated today, which makes machine learning more and more useful today than it was a decade ago or two decades ago, or whatever that may be. So where do we start? We talked about the decision-making process. So where do we start, and what problems are we able to solve with machine learning, right? So the book goes into breaks it down into 4 different kind of categories on what problems are, may be useful for machine learning, what maybe not, depending on your situation. And so I'm going to kind of regurgitate that a little bit, because I think this is kind of a good framework for those of you who may not be, have a very technical background, to be able to think of different problems and what they mean, and if machine learning can actually be useful within the context of those problems. So those 4 areas are known knowns, known unknowns, unknown knowns, and unknown unknowns. So the first one, known knowns, is kind of this the situation where we know the extent of where our knowledge lies, right? We know what we know. And this is kind of the context of when we have a lot of data, that rich data set we were talking about. Machine learning can work very well when we have a lot of data on something. And this is kind of that sweet spot for today. So what are some examples? Well, we talked about fraud detection. A lot of the fraud detection that happens in credit cards today, you may never even notice because they've had so much data to be able to use these machine learning algorithms that it all happens behind the scenes, and a lot of it you never even notice, or fraud gets detected before it even gets to you. Medical diagnosis. Now, there's a lot of data that gets captured for medical diagnosis and diseases and things like that. And so disease detection, most notably using it on well-known diseases like cancer and things like that, is a place where machine learning can be very useful because we have so much data. And then we also talked about, that baseball example of Moneyball as well. And there's a lot of examples today, but these are kind of a few to get the ball rolling, to get your mind thinking about, what this all means. The second thing is known unknowns. So we know exactly kind of where our knowledge ends or what we don't know. So even the best prediction models require large amounts of data, right? We kind of talked about this. Now, we know our model is going to perform poorly, or our prediction might not be very good when we don't have a lot of data on some sort of situation, right? And we may know that we just don't know enough to be very accurate with machine learning. And this might just happen because some events are rare. So getting data to predict very rare events might be challenging because we just don't have a lot of data on those events, right? When they occur, and really knowing the ins and outs of all that. And a great example of this is for those of you who may have experienced an earthquake, there's a lot more people that have experienced, let's say, a magnitude 1 or 2 or 3 earthquake versus a magnitude 8 earthquake, right? Because those higher magnitude earthquakes are a lot rarer than smaller ones, right? And so it's easier to predict, the non-rare events or those smaller earthquakes than it is to say, okay, when's the next 9.0 going to hit the West Coast? It's very tough because we don't have a lot of data on that. And no matter how great you get on kind of the talking to somebody who knows a lot about geology and all that stuff, there is a limit on them just not having enough data points to be able to predict it at some very high level of accuracy. So this is kind of an example of a rare event that runs into this kind of context here. Now, on the other hand, people in some instances can be very good at predicting with very little data, right? In this kind of known unknown realm, people can be very good at that. And an example of this would be recognizing a face after seeing it once or twice, maybe from a different angle, after years apart or whatever, right? Let's say you see a classmate from 10 years ago, and things about their appearance have changed, or they're obviously a decade older or whatever that may be, and you're still able to recognize them even though let's say you saw them from an angle or whatever that may be, which is kind of neat that people can be able to recognize someone based on very little data, right? So this is kind of a neat example in the other direction of known unknowns. So this third kind of realm of possibilities here is unknown unknowns. So we don't know the extent of what we do know, right? We don't know how much we don't know. And what this means is it's just very tough to make a prediction when you just don't know what you're predicting in the first place. And one of the things, I guess, that these events are called, or they're called black swan events, as some people call them. And this goes back to the Europeans when they first encountered an Australian black swan. When the Europeans first went to Australia, their whole context of what a swan was this white swan that existed in Europe, and that's all they knew existed, right? If you would ask somebody before they, ventured to Australia, if anything other than a white swan existed, they probably would have said no, because there was no way that they had any sort of reason to believe that a black swan existed. Well, They go to Australia, and what do you know? A black swan exists there, right? So events that are kind of in this realm of unknown unknowns, where we just don't know what we don't know, tend to be called black swan events by a lot of people because of that. And there's some other historical consequences of this too. If you were sitting in the early 1990s, the music industry was pretty high class at that point. You know, it was booming. CDs were getting huge. You know, it was really good time for, let's say, artists who, you know, had a lot of CDs out and things like that. Well, in the late 1990s, about 1999, some 18-year-old developed Napster, right? And so the industry, of course, hasn't been the same since. Now we have iTunes and Spotify and all that fun stuff, music streaming, and everything's, you know, completely different than it was in the 1990s. But if you were sitting there in, let's say, 1991 or two, there would have been no way for you to predict the advent of, let's say, iTunes in the early 2000s, right? Because it was kind of that you just didn't know what you didn't know. There was no way to predict that. In the same way that if you wanted to predict the occurrence of COVID-19 5 years ago, it would have been very tough, right? To say, okay, in 2020, we're going to have this disease. It's going to be, you know, COVID, and this is what's going to happen. There'd be no way for you to predict that because it's kind of, you know, this black swan event, right? And so there's no really clear advantage for, let's say, a person to be able to predict this or a machine learning algorithm to be able to predict this, because this is just kind of one of those situations where it's just tough. Now, the last one is unknown knowns. So we don't know exactly what we know. Now, a big weakness of machine learning is, or prediction in general, is you can provide kind of wrong answers with a confidence they're right, right? This goes back into that, you know, if your data is biased, you know, based on everything you know, you think you're right, but ultimately you may be wrong, or it may be, you know, not a very good prediction to begin with. Now, humans, in some sense, can understand their inaccuracy, right? They might not be confident in their prediction. They might say, okay, I'm, you know, about 90% sure that this is right, or hey, I'm not really sure, but this is what I think the answer is, or whatever that may be, right? We make decisions based on that all the time. And, you know, data can also inform decisions, but it can also come from decisions. You know, ultimately, do you understand the process that generated that data? So you can give a machine learning algorithm data and have it predict something, but sometimes it comes down to, you know, knowing the process or understanding the process that generated the data. And an example with this was, you know, years ago, they tried to use machine learning to redact confidential information on documents, right? Things that lawyers would do. And they thought, okay, well, we could probably simplify this and use machine learning to leverage and make this a lot easier for our lawyers and all that fun stuff, right? Well, what they came to find out was it mattered so much on knowing the context of how that data was generated, right? What actually went into that case, that document, right? So that it was very hard to be able to use machine learning to be very accurate in redacting the right confidential information they wanted from those documents. So this is kind of an example of what I mean, where data can inform decisions, but it can also come from decisions. So we're going to go into an example, and for those of you who you know, may have heard one of my talks before, these are examples that we've talked about before. But can our data be biased, and how can it be biased? So a good example of biased data is in the 1980s, they tried to use machine learning to build an AI to play chess, right? They wanted to see if they could beat these grandmasters, these people who were just the top chess players in the world, see if we could build an AI to beat them. Now they use hundreds and thousands of moves at these grandmaster games to be able to train this AI, to be able to train this piece of machine learning to be able to play chess. And so everything seemed great. They thought, you know, they were doing great and they were having a lot of success until they actually had it play some sort of opponent. And now the AI established its strategy. It launched an attack like anyone would. And then immediately it sacrificed its queen, right? So they're thinking, oh, wow, this isn't good, right? We started the game and now it just lost. So this, you know, back to the drawing board. So why on earth did this happen? So why did this happen? Well, The answer comes from that bias data that we talked about. So when a grandmaster usually sacrifices its queen, it's usually this brilliant, decisive blow that leads to a win, right? It's, you know, very this very great move that's going to allow them to win the game. Now, because the AI was trained on this diet of grandmaster games, these best chess players in the world, it kind of ran to this conclusion that, well, if I can predict that I'm going to predict that giving up my queen is the easiest way to victory, because every time, or most of the times that a queen is given up by these really great chess players, they win the game, right? So that was kind of the easiest road to victory, or so it thought. And so it all come back to the data that they fed it, and how that data was very biased, right? And so you can, if you want to learn more about this, you can read more about it in the book Deep Thinking. But this is kind of an example of how data can actually be biased, right? Another example, when we talk about machine learning to be able to solve problems, this is an example based on the known, right? The rich data sets we talked about. So sometimes you can actually use human and AI prediction to become more accurate, right? You can use a combination of the two. So back in 2016, there was a group of Harvard and MIT researchers that tried to train an AI, or tried to train a machine learning model to detect breast cancer. And it used both human and machine prediction, and they were able to hit some crazy high accuracy, right? 99.5%, which is better than either could do individually. If they were to just have, let's say, a machine learning algorithm look at it versus just have, you know, an expert radiologist look at it, right? This was more accurate than they could do, you know, by themselves. So how on earth did they do that? Because that's really crazy and that's awesome. So how did they do it? Well, one of the things they found out from their research was that humans, or in a sense, these expert radiologists, were very accurate predicting when cancer wasn't there. Now, the AI, on the other hand, was more accurate than the radiologists at predicting when cancer wasn't there, right? So the humans are more accurate at predicting when cancer was there, and then the alternative for the AI. So what they did is they filtered it through the AI first. So they had the machine learning algorithm kind of look at it and look and find out when cancer wasn't there. And then they fed the rest of the results to that human pathologist for further review, right? So they fed it to an expert. And that was ultimately how they were able to be so accurate at detecting breast cancer, which is pretty cool and pretty useful, right? And in the medical field, you know, earlier detection of breast cancer, and you can treat these patients and all the consequences that come from this. So what can we learn from this? Well, you know, we know that machine learning works very well with routine rich data sets, right? We already talked about that. And another thing we kind of learned from this is, well, you can use kind of a combination of the two to be able to achieve aims, you know, in different situations, and decision making in business and things like that. And there's other examples out here, but ultimately, when, let's say, your machine learning can't make, you know, the entirety of a prediction with confidence, you can use human intervention or human prediction in addition to that, right? Just similarly how they just did it here. So I know there's a lot of stuff I just covered today. So I'm going to give you kind of 2 key points to kind of take away from this talk. If anything else, you know, you walk away with, and hopefully you learn something. So number 1, machine learning is going to continue to change our lives. It's going to be able to solve problems, and it's going to open up this whole new world of jobs, services, platforms, and applications. And it'll bring challenges too, like security, network reliance, and all that fun stuff that comes into play. But it's going to be crazy to be able to see how that impacts our lives, you know, over the next few decades and in the future, based on what we're able to do with it within, you know, decision-making processes. And it's going to impact business decision making, you know, breaking down business decisions like we kind of did when we looked at that, you know, anatomy of a task or business decision later on. We looked at that diagram, gives us kind of an idea of when and where machine learning can be useful, right? So when it can be useful inside your business, and how you can actually use it, you know, to make your lives better. And ultimately, recognizing the current limits of machine learning allows us to exploit its strengths, combat it, you know, combat its weaknesses and things like that, similar to how those researchers developed that AI to detect breast cancer, right? So knowing the ins and outs allows us to make it even better in the future. So that's it. I hope you guys learned something and got some value out of that talk today, and we'll open it for those of you that have questions.
Yeah, thanks, Stephen. I had some questions from other startups that couldn't make it offhand, but in some ways, I'll give priority to everyone to hear. If you guys have any questions, offhand, I know pretty much you can unmute yourself and you can ask one. Choose on. Drew, you have a question?
Yeah, I do have a question. So, as we talked before, I'm in the entertainment and sort of gaming industry regarding applications. And I was wondering if machine learning is something that we could use for like an intelligent skill-based matchmaking within these games. Is that something that's possible?
I would say, yeah, it's definitely a possibility. And sometimes machine learning comes down to the context of your situation too, because there's times when, it can be very useful, let's say in different matchmaking situations, and times that it won't. If you can, ultimately, if you can find a way to, let's say, gather data to be able to feed something like that, you could play around with it and see how useful it may be. Because it might be useful in the entirety of that process, right, of matchmaking, or it might only be useful in certain situations. Does that help?
Can train it. Yeah, but you're saying you can kind of train it based off of the amount of data we can pool together and feed it so it can learn from that. Okay.
Yeah, the same way that you may learn from, let's say, experience and things like that, right?
Yeah.
So think of it as like pattern recognition, right? So if you can, look for the same way that you look for patterns when you learn how to figure out how to solve an addition problem or a multiplication problem, it's going to do the same thing with that data set, right?
Yeah. Okay.
Does that help?
Thank you. Yes, it does. 100%.
I know we have some other startups too that's on. Andreas, I was like, Andreas, have any questions? I called him out.
Yeah, for what we do a lot, the biggest issue is being able to judge if a data set is biased or is considered good. So how would you go about, and I know that every case is very specific, so I'm trying to figure out how to ask it generally, but what are some criteria that you would recommend for making sure that you're not bringing in junk data?
I would say that it is tough. I would say one of the biggest things that you could probably do is for people in your team that are kind of working through that and trying to figure out if their data is biased, you could do the same techniques you might do with overfitting. Do you know what overfitting is?
No, I don't.
Okay, so overfitting is kind of a term used by data scientists when the result is kind of really fitted to that specific data set. So if everything let's say if all the data you give it is very specific or very biased towards some certain scenario, and you give it something outside of that realm, right? It's not going to be able to predict that very well, right? So you end up with sort of this biased prediction. So there's ways for you to be able to break your data down into different subsets and play around with that to see how biased your data is. And there's ways you can avoid overfitting and things like that. But I would say that I don't want to get too specific here. I want to give something, I guess, pretty valuable. I would say look into overfitting and some of the techniques that they use to avoid that, because that would probably help you figure out how biased some of that data set is. And sometimes it's tough to know until you actually do some real world testing, right? This is something that Google runs into a lot. Sometimes it takes until to find out how biased, let's say, some search results are. It takes a lot of people to actually have it happen in the field, right? And so sometimes, unfortunately, that's the best way. But there are ways you can mitigate it with techniques to avoid things like overfitting and things like that.
I appreciate that. And in general, just a lot of what we do is focused on agriculture. So also we have AI interest in business segmentation, that sort of thing. But we get asked a lot in agriculture to combine different data sets. So like multispectral imagery, ground sampling, those sorts of things. There's also, there's some variability in the accuracy of those. Like some are down to like centimeters, some are measured in meters. So we have some induced error in that. There's also environmental variables, and we run into this concept of, is it better to try and collect as much as possible because you don't know necessarily which variables are the key contributors to a model, or to keep it much more simple and try and guess the three most important variables and focus on that?
Yeah. I would say collecting more variables is never a bad thing. I mean, you can always simplify it down from there, and it gives you more, I guess, more to work with. There's trying to think of the term that's used to give you some context here, but there's techniques that let's say you use in data science if you have a lot of different variables to be able to find out, let's say, which will correlate to the end result you're trying to get to, right? Or which ones are more meaningful than others, because there might be a term that's used is called noise. I don't know if you've heard that before, but there's you want to be able to mitigate noise in your data, right? So things that may exist or variables that you keep track of that aren't very useful to what you're trying to predict, right? Like what you're saying, where it may come down to there's only 3 or 4 or 5 things that really make a difference on you making that decision or making a good prediction, right? And there may be a dozen other things that you find you can keep track of, but they don't really impact it as much. And so there's techniques you can use to kind of let's say you can weight different features or different variables that you keep track of, right? And there's we could talk more about it too, and I can point you to some examples here, but
cool. So if I could summarize that, it's basically, as long as you can find that it's within whatever quote unquote acceptable quality control is for the data, it's better to collect more than do something like a modified regression analysis to figure out which variables are most important.
Yeah, I'd say from my experience, I think it's never a bad idea to collect more, because it gives you, ultimately it gives you more to play around with, right? There may be something that you didn't keep track of 5 months ago that now you keep track of now, and you find out, hey, that actually has an impact on us making that decision, right? So it may allow you to, mold and may allow that solution to kind of evolve over time, right?
Yeah. Cool.
Does that help at all?
It does. It kind of goes at a high level. What we're trying to figure out is, obviously, of course, the length of the study is impacted by how many variables, and also the potential for noises. But that's continuously an issue. Project for project, the available data sets can be quite different.
Yeah, and you could I would Google feature selection, because there's different ways you can look at feature selection to be able to find out or give you an idea or some place to start, or some place to be able to test to figure out what sort of features or what sort of variables you're keeping track of that that mean a lot to what you're trying to predict. So that could give you a place to start.
Cool. Yeah, we'll do that. Appreciate it.
We got a shout out from Austin. He says, "Thanks, Stephen. Good to see you guys." That's great. Austin, if you have any questions, that's good. Austin's toy. We might have Austin on tech school later on. Definitely has skills in DevOps and stuff like that. But thanks, Austin, for coming on. Well, I always do a little shout out to Sam. He's got a head of Innovation Hub at Cal State San Marcos and different things. Sam, it doesn't have to be anything about machine learning or anything of that nature, but do you have any questions or things you've seen some of your startups needed to use prediction or anything like that?
I was just going to make a comment because I always present to students, the importance of artificial intelligence, machine learning, and I always phrase in a way that if you look at the last just over 10 years when the iPhone was introduced, how much the world has changed, right? How many industries have been disrupted? We look at transportation, how we access transportation, how we access entertainment, how we communicate with each other. And 10 years ago was completely different than what it is today. And companies have spun up and become extremely wealthy, and others have died off because of not being able to adapt to those changes. And people ask, what's the technology for the next 10 years? What's going to be the most disruptive? What's going to make the biggest difference for companies and for startups? And I would have to say that machine learning and artificial intelligence, that's really the technology that's going to disrupt the most in the next 10 years. There's other cool technologies like blockchain and things like that. But really what it comes down, I think, to is this is the big change that will drive innovation, will drive value creation, will drive businesses into the future. So it's a good thing to learn and understand. You don't like we were saying earlier, that you don't necessarily need to know all the ins and outs of the computer science behind it, because there's a lot of great resources already available, but you have to be able to use the technology and apply it to whatever problem you're trying to solve. And if you can do that, then you're likely to become more successful going forward.
No, that's good. That's good feedback, Sam. And I know you're always working with the kind of more non-technical founders. So I think that's wise. It looked at this point, we're doing pretty good on time. Stephen, what I was going to do is just do one shout out to, I know, I'll ask Sunny. Sunny, can you hear me okay? Sunny's the one that came from our cohort.
Yes, I can hear you.
Okay.
Excuse the background noise. I'm still running errands.
Yeah, no problem. Thanks for coming on. You're holding down the fort for the cohort. But I just gonna say thanks for coming on. That's all.
Of course. I enjoy these lessons, these lectures.
Yeah, that's good. That's great. I know we also have Chris and Andy. If you guys have any other questions, that'll be fine. You can post them on chat or reach out at hello@fokcus.com too. If you have any questions, I think that's really important. I think just having access to to people like Stephen, myself, and other groups, it's good. As startups, we actually have a hard time sometimes to reach out on complicated things like who do I talk to and things like that nature. So that's one reason why we started tech school. Stephen, anything else you want to add? Is there any closing thoughts?
I would just say that, like you said, if anyone has some, resounding questions, Andres, I know you asked a few, and if you need some resources, feel free to reach out to hello@Fokcus, or you can, email me at Steven@Fokcus, and I'll do my best to point you, in a direction to help you out too. And if you guys think of any questions that are kind of bugging you on you, want to know the answer to, then I'll send it my way or Curling's way, and we can do our best to tell you what we know, or at least point you in the right direction. So
that's great. Sammy, any final thoughts? You want to do Innovation Hub? Any shout outs?
Just kind of, I mentioned this last week and just wanted to mention again, we're going to do a summer innovation challenge, and the more things continue on, the more important I think it becomes, just looking at how we can solve some problems related to schools reopening. I think there's going to be a lot of challenges. And so the Innovation Hub's going to sponsor a summer innovation challenge. You guys, anybody who wants to participate in that will be able to submit some ideas about how to solve some of those problems. And so look for some more details coming. If you want to, you can go to the website at CSUSM and search CSUSM Innovation Hub. You'll pull up.
Yeah, if you give me a link, I'll put it on the bottom of the YouTube video too.
Perfect.
Sam, offhand, is it everyone invited to help in that challenge, even if you don't go to CSUSM?
Meaning, can anybody submit?
Yeah.
We have a meeting here, and what I might propose come Monday, we'll have a meeting to finalize everything, is that we might have a community competition and a student competition. So it can be open to everybody.
That's great. Okay, that's good. That's good. I'm on the board of Startup San Diego. Like there's probably a few other groups would like to tackle that education, at least make it more efficient in some ways. I would just thank everybody for coming on. Stephen, excellent job on that, and for all the cohorts, even for next week, we'll continue as we've been doing. Thanks, Drew, for all your questions, and Andreas, that was great questions too. Thank you guys. Follow us on Instagram and Facebook, and I think what we're trying to do in some ways is reach out even beyond just our cohort in San Diego. So hopefully this is helpful. Give us some feedback there. Take care, Chris, Andy.
Awesome. Have a great day. Thank you very much.
All right.